question to ask you. Now, you've been measuring countertops or bench tops for the past 15 years, and you've been measuring them digitally for 8 years. And recently, over the past 2 years, you've been measuring in 2D and 3D, templating in 2D and 3D on construction sites for different industries, joinery, metal fabricators, and panel fitting companies, to mention just a few. But I thought one of my questions for you is, what's the biggest benefit that you have found from switching to 2D, 3D templating?
Yeah, cool. So, I suppose when we first started measuring bench tops, years ago, the first machine that I had, it just would measure in 2D. So effectively, a horizontal plane, you might be measuring up against a couple of walls, maybe a wall at the back, and then you've got to measure the cupboard fronts. And then if you wanted to measure the splashback at the back, it's like a new page, and you draw that in, and effectively, when you look at each file, it's just flat or horizontal as it would sit on a CNC or whatever. So that's good, but once I started measuring in 3D, I realized, particularly the way technology is going, the advantages. So, for example, if you carry on with that analogy of a kitchen, nowadays, you might have an island, and all of a sudden it's not just a waterfall leg, but it's a waterfall leg with a box section coming in, and then it might even trapeze down onto a totally different plane. And so when you're measuring in those situations, or bathrooms where you might have floor to ceiling sheets and then nib walls coming out, when you're measuring, if you're just measuring in 2D, you can actually get quite lost, because you're like, where did that one start and where did that one stop, and how do they all connect in? Being able to measure in the 3D but still see each individual, either vertical plane or a free plane or horizontal, is really good, because it helps you to be more accurate. Plus, downstream, what I'm starting to see is a lot of the software that people are using. So you might have lovely stone with a lot of veining in it, and a homeowner might like to see, how does that all actually come together? Now, you could have a generic one done from your architect, but actually seeing the slab you have and how that all connects, that can only truly be done with a 3D template or drawing. So while it's not probably demanded or 100% needed now, the opportunities that it opens up for the future, I would say that it's going to become a lot more necessary.
Cool. And as far as in industries such as joinery, metal fabricators, you've obviously been in the stone industry, but moving into these other industries, what do you see are the difference in measurements and in the way they process the measurements?
Yeah, so not professing to be any know-it-all or anything, but from what I can sort of gather, having now spent a couple of years sort of delving into other industries, I think what's unique about the countertop or benchtop industry is the fact that the sheets that you're dealing with are so expensive. So, you could be anywhere between, sort of $800 to $10,000 for a particular sheet. Now, when you come in to measure, you've got to get that right. And you do not want your guys coming to site and then them trying to fit it and it's not fitting, or all of a sudden it's very short. So I would say that stonemasons as a whole, or as an industry, have got really good at coming to site, measuring, and then getting that manufactured in the workshop, and then coming in and it fitting. And the thing that's pushed them to do that is the expense of the material. And of course, that makes the workflow awesome. What I've seen in the other industries that I've been in is perhaps, glass might not be as expensive per sheet. A piece of plywood might not be quite as expensive. And so people have kind of got that attitude, if it's not broken, why do we need to fix it? So they're still measuring using perhaps tape measures or simple handheld laser and a square or something like that. But what I think people haven't really fully thought about is the fact of, imagine if you measured this really accurately, got it manufactured off-site, and it comes in and it fits. They tend to just think, we already measure doing this. But it's not just that. There's a lot of downstream things that happen. So as far as the actual measurements go, whether you're measuring a bench top or you're measuring for metal facade, for glass, or whatever it might be, lasers, most of the, machines that measure for this sort of project, they're generally within 10 meters. It's generally that sort of 1 to 2 mil accuracy. And then for every other 10 meters you go after that, you might lose another mil. So if you're talking 30 meters, you could be 3 to 4 mil out, which in the context of things, I would almost challenge anyone else. When you start dealing with those sort of things, there's not a lot of other things that you can actually get that accurate once you get out to that. So, to answer your question, it's other industries are different, but they're kind of the same. It's measuring, making, and fitting.
Oh, cool. And how do you see, as far as digital templating for the future of digital templating and construction, where do you see that heading for workflow across industries?
Yeah, it's interesting. Definitely learning in this space. Probably the easiest way is just recently did a job and to try and get what we're trying to do and look at is we were asked to measure a set of stairs. It's 5 stories, glass going up each side of these stairs. So basically what we had to go and do is measure the stairs. So that involves the bottom part of the stringer, which comes up, and then it goes a level and then up on another angle again. And that happens on both sides. Measure that underside of the stringer and the treads. And then from that, you're able to capture the glass and design the glass on those. But then, I've been back to that side a few times, and I stopped and I looked and I thought to myself, they're actually getting somebody separate to come in to do the handrail. But the glass is going to have the holes designed in it for the handrail. And combined with the file that we have, because it's done in 3D, there is no reason why that handrail couldn't be manufactured off the same file. And then it doesn't even stop there. Like, I stood back again, and then if you have a look underneath, it's all in it's all been out of steel, big steel beams fabricated that the stairs sit on. And builders were there measuring and going back to the drop saw and cutting a whole lot of timber to glue and screw on underneath in preparation for plywood. So it's my belief that the building company could actually, there's no reason why you couldn't actually make a whole cut list for the timber being glued and screwed on, and by extension of that, the cut list for and get CNC'd out all the plywood that was covering it. So from one singular measure, there's so many flow-ons, but the thing restricting it is basically, first of all, you can only do that if you digitally measure. Has to be in 3D, and everybody needs to talk to each other and be on board and make it work. And that's probably, if you ask me where's it going, I think that is where a lot of the building industry will need to go to is prefabrication. But it's kind of like, I feel like there's almost 2 different levels. There's the level of architects and people doing, they might have a BIM drawing and everybody's sort of going off that, and you've got your surveyors doing the big grid lines. But then once you come down a little level, most of your sub-trades, they're not tapping into this technology and nobody's talking to each other. And that's where I'm like, I think there's a space in here.
So why does, though, a lot of people speak about 3D scanning, point cloud, why does a 3D scan not just be able to serve all fabricators and sub-trades so that they can use the same scan and be able to fabricate off that?
Yeah. First of all, I have to say I've never used a 3D scanner. So, I can't sit here and say it's not the right tool. But I have done a lot of research and I've talked to a lot of people who have either had somebody come in to do 3D scans or they've actually gone and purchased one themselves. And to be honest, it's what I said before. Like, I feel like there's obviously a lot of situations where 3D scanning is awesome. It's amazing technology and it can capture a lot of data. But there's a level down where the technology or the accuracy, it can't be trusted quite enough yet, because you don't see anybody just doing 3D scans and then getting glass made off it. You don't see anybody doing 3D scans and getting their bench tops and waterfall legs and all of that made off those scans. Part of that, and as I said before, I'm not professing to know everything about doing 3D scans. I know that it comes down to a bit of the operator, but it's my belief that the technology, that 3D scanning technology, is not ready yet for the things that we're speaking about, for your sub-trades coming in, for glass, for stairs, for countertops, for joinery, that sort of thing. It's not actually there. The one other little problem that I can see with 3D scanning, particularly for those trades, is that it's so much data that they then, like, cool, you've got this massive file in the room, somebody still has to go in and effectively extract all of the little points that you need to make what you're trying to manufacture. And that takes time. So it's almost better to just spend that time on site and just capture what you need.
Oh, cool. No, that's all good. And I suppose my last question is, do you ever make mistakes?
Never.
Or whatever.
No, that's not true. Yeah, look, you got to be truthful, and yeah, I do. The thing is that whenever, it's like anything, anybody can make a mistake. What I've sort of learned over the years is when you have processes and systems, and if there is a problem, you gotta stop, check, and work out why the heck did this happen. Pretty much, it's my belief that it's never really. I don't go blaming machines. With a laser, you pretty quickly learn they are deadly accurate. The things they don't like is they don't like black can absorb the laser, so you can end up with a slightly inaccurate measurement. But that's a simple fix of, if you think it is too dark, the machine will often actually tell you that it hasn't got enough data back to even capture a real point. But if you're worried, it's simple, a matter of put a bit of tape over it and you'll get an accurate measurement. You might learn reflective, you can't shoot straight onto a mirror. You might have a piece of quartz that's transparent. So you do learn a few tricks, but I don't really get mistakes from that because you know what you're doing. It's generally just human error. Like if you're measuring a bench top and it's only meant to overhang this far, and you've got the original line and just typing away or clicking away, you add an extra 300 mil onto it. But percentage-wise, I'd have to say that you make way less mistakes digitally measuring than any other method, traditional method.
No, that's all good. Well, I better get you out the door, otherwise then you'll be late for the job. But thank you very much. And yeah, I might have to rope you in for another few questions one day.
You're lucky.